Let's look at section 2.4, set operations and Venn diagrams with 3 sets. In this section, you will learn how to perform set operations with 3 sets, use Venn diagrams with 3 sets, use Venn diagrams to prove equality of sets. Perform set operations by starting inside the parentheses first. So you would do A union B, and then do A union C, and then find the intersection of those two groups. Use deductive reasoning to prove the equality of sets. Recall, deductive reasoning is when you use general statements to come to a conclusion. This is De Morgan's law. So A intersect B, the complement of that, equals complement of A union complement of B. And then you could reverse that. You could do A union B, the complement of that, equals A complement intersect B complement. Let's look at an example. We have the universal set, A, B, and C. So we want to do A union B intersect complement C. We're first going to find the complement of C. So here is C. So let's do the complement of C. So here's the whole set. So we're doing everything but C. So it would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we're going to do A union B. So here's A and B. So A union B. A union B would be 1, 2, 3, 4, 5, 6, and 8. Now find the intersection from step 2 in the complement. So we have this and this. So we want to look at these numbers that are the same with the complement. So they both have 1. They don't have 2 and 3. They don't have 4. 5 is the same. And 6, 8 is the same. Okay, let's look at the next one. We have A union parentheses B intersects C. So we're going to start inside the parentheses. So B intersects C. B and C. So we want to find what they have in common. So it'd be 1, 2, and 6. It's just B. Now we want to union that with A. So here's A. Here's this one. So rewrite it. So union A with this one. So we want all of them. 1, 2, 3, 4, 5, and 6. Okay. Let's go to the next one. A union B intersect A union C. So A union B is the first thing that we'll do. A union B. It's all of them. 1, 5, 8, 9, and 10. And then A union C. 1, 2, 3, 5, 6, 8, 10. So I just listed all of the elements from A and C. So then we want to do the intersect of that. So what do they have in common? So I think it's easiest if I circle. So not 2, not 3, 5, 8, not 6, not 9, but 10. So that's what they have in common. So A union B intersect A union C is the ones that they have in common. 1, 5, 8, and 10. And the next one, A union B union C intersect, or the complement of that. So remember De Morgan's law. So This is the union of all of them with the complement. So let's select this one. So what we could do is we could do A, okay, because it's the union, but it's a complement. It would be the same as the intersect of the complement of each. So let's see. We could do it that way. Let's see. So I'm going to do A complement would be, this is all the numbers 1 through 7, natural numbers. So 2, 3, 4, 5, 6, 7. B, 3, 4, 5, 6. C prime, 1, 2, 3, 4, 5, 6, 7. Okay. So now we want to do the intersect of all of them together. So let's see, do they have anything all in common? A and B have 4 and 5 in common, but they don't have anything in common with C prime at all. So this is no solution. There's nothing there. It's an empty set. Okay. This is a Venn diagram. It has 3 sets, and then you have all this little shading. So region 5 is right in the middle. That is what's in common between A, B, and C. Region 2 is what's in common with only A and B. Region 4 is what's in common between only A and C. Region 6, which is right here, is what's in common with only B and C. Region 1 is the elements of A that are not included in B or C. Region 3, all the elements of B that is not included in A and C. And region 7 is all the elements that is not included in A or B that's in C. Region Region 8 is going to be the universal set that is not in A, B, or C. Okay, so let's look at this next example. So on this example, let's go ahead and write down all the elements. So A would be every element in all of A. So including what's in common with C right here, and what's in common with B, and what's in common with B and C. So it will be all of those elements. So 11, 3, 12, 6, 5, and 7. A union B, that's everything in common with B. So, no, not in common, sorry, everything A and B. So it's going to be all of these 11, 3, 12, 6, 5, and 7, because that's all of A. Oh, I don't want to close that yet. And then all of the elements of B. So I've already included these two, so I just need to include this. 1, 2, 10, and 9, right? Because it would be all of those. So 12, 5, and 7, and then 1, 2, 10, and 9. Okay, intersect of B and C. So it's everything in common with B and C. So this is in common with B and C, but not A. This is in common with B and C and A. So it's going to be 5, 7, and 9. Okay, C prime, so it's a complement of C. So it's going to be everything that is not in C. So see how this whole circle includes that? So it's going to be everything outside the circle, including the universal set where you have 4 right there. So I'm going to start with 11, 3, 12, 1, 2, 10, and then that 4. Okay. E is A intersect B intersect C. So it's all of the items in common with A, B, and C. So that would be this set right here, 5 and 7. The next example is a real world operations set. So let's see. A math tutor working with a small study group has classified students in the group by whether or not they scored 95% or above on each of the 3 tests. The results are shown in the Venn diagram to the right. Use the Venn diagram to represent the set of students who scored 95% or above on exam 3 in middle school form. So we're only looking at exam 3. So we just want to know who all scored 95% or higher on exam 3. So it would be all of these. Q, L, O, Flo, Gus, and Leon, or Lon, just on exam 3. What if we did exam 2 intersect exam 3? So we would find all of them that made 95% on exam 2 and exam 3. So it would be, I should have included Pat here. Sorry, forgot Pat. He was kind of hiding there. Okay, so it'd be Pat, Al, Al, and Ollie. All right, so that is it for these notes.